In this lesson, we are going to move on with our probability to what we call OR probability. So what we're going to do is show you a little example to begin with. I have a set of circles and stars, and I want to know what is the probability of purple or circle. So the first thing I'm going to do is count how many purples I see. I see 5 purples. And then I'm going to count how many circles I see. I see 5 circles. So if I put those together, I'm thinking I have 10 total items that are purple or circle. Couple of problems with that. First problem is I look and I only have 8 figures, so I can't have 10. Second of all, I do know that I've counted some of these twice. So if we are going to count how many are purple or circle, the first thing I would do is count how many purples I have, which is 5. And then I would count how many circles I have that I didn't already count. So that means I have a total of 6 items that are purple or circles. We could also say that I have 5 purple, I have 5 circles, but I'm going to take away the ones that I counted twice, no double dipping, and that answer would be 6. So we can either count or we can use our formula where we make sure we always take out our doubles. In other words, don't count them twice. So let's take a look at our first example. Find the probability of picking a number from 4 to 40. Well, first of all, we have to count the total amount of numbers that we have. And so we can count them one at a time. Or another trick to remember is I can subtract 40 minus 4 is 36, but there's always one more because when we subtract, we're excluding one of the end points. So now we want to count the even number that we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We have 19 numbers out of our 37 that are even. Now we want to count the numbers that are multiples of 3. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So we have 12 numbers that are multiples of 3. In other words, we could count by 3s. But we also notice that we have some that we counted twice, so we have to take those away. So I counted this one twice, that's 1. This one twice, that's 2, 3, 4, 5, and 6. Looks like we counted those twice. So that means that we would subtract those. So 19 plus 12 is 31, and 31 minus 6 would be 25. So we'd have 25 over 37 as our probability of picking an even or a multiple of 3. So next it says let's pick a prime number or a perfect square. So I'm going to erase my marks on here and we're going to start over with our numbers and we want to pick prime. Now remember, prime numbers are those that only can be divided by 1 in itself. So that would be 5, 7, 11, 13, 17, 19, 23, And then we would have 29, 31, and 37. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 numbers that are prime out of our total of 37. Then we're supposed to pick our perfect squares. And remember, our perfect squares are when we multiply two numbers times each other that are the exact same number. So 2 times 2 would be 4. So we have 1, 2, 3, 4, 5. We have 5 that are perfect squares. Now notice I didn't count any of those twice, so I do not have to subtract. And so the probability would be 15 out of 37. So let's take a look, and the next one we want to do is we want to pick multiples of 2. And then we want to pick multiples of 5. So when we pick multiples of 2, well, multiples of 2 are even numbers. So since we already know the even numbers, we would know there was 19 of those that we used in our first problem. Now we need to know the multiples of 5. So when we're picking multiples of 5, we have 5, 10, 15, 20, 25, 30, 35, and 40. 1, 2, 3, 4, 5, 6, 7, 8. 8 of them. But we have to also know that there are a couple of these numbers that were also even at the same time, which is 4 of them. So we're going to take those 4 away because we didn't want to count them twice. So 19 plus 8 is 27, minus 4 would be 23. So we'd have 23 out of 37 as our probability of picking a multiple of 2 or a multiple of 5. In the next example, we're going to use some playing cards. So let's find the probability of selecting a card. First one that's red. Well, we know red is 26 cards out of 52. And spades are 13 spades out of 52, but there are no doubles because spades are not black. So we don't have to subtract anything. We get 39 out of 52, and we could reduce that. We could divide both by 13, and so we would have 3 out of 4. Then if we want a black card, we know that there would be 26 black cards out of 52. And this time a king. We know there's 4 kings in a deck, but we also know that 2 of those kings are black, so we have to take 2 of those away. So 26 plus 4 is 30, and 30 minus 2 would be 28 out of 52, and we can reduce that by dividing by 4 and get a probability of 7 over 13. Next question we have is diamonds. We know that in a deck of cards there are 13 diamonds, and there are 12 face cards in a deck of cards. We do know, however, that 3 of those face cards are diamonds. So we would add the 2 together, 25, and subtract 3. We'd have 22 out of 52. And when we divide those both by 2, our final probability would be 11 out of 26. So what happens when we roll a die? Well, we know there's 6 sides on a die, numbered 1 to 6. Getting a 3, 1 out of 6. An even number would be 2, 4, 6. That's 3 of those sides. And in this case, there are none that we double counted. So we get 4 out of 6, which reduces to 2/3. In this example, we know there's 1, 5. And then the odd numbers would be 1, 3, and 5. But we know that we just counted the 5 twice. So we get a probability of 3 out of 6, which is 1/2. So remember, when you're doing probability, you add the 2 categories together, but we always subtract the doubles. We do not want to count them twice.